Let's play a game. I have 3 tasks for you that sound incredibly simple, but are actually impossible to finish. Task number 1. You have exactly 1 minute to draw a specific shape on a piece of paper. Here is the exact rule you have to follow. You must draw the most complex shape that cannot be drawn in under 1 minute. Take a moment to think about that. If you actually manage to draw the shape in 59 seconds, you failed the rule, because the rule says this shape cannot be drawn that quickly. It's a trap. A time-based rule becomes impossible to follow the moment the physical act of finishing it proves the rule wrong. Let's move to task number 2. This time, instead of drawing, you're going to write a title for a new book. Your publisher gives you a very specific rule for the title. It has to be shortest book title not possible in less than 11 words. Let's count the words in that title. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our title is 10 words long, but the rule says it's not possible in less than 11. It breaks its own rule. Instructions like this fail because the description itself violates the very limit it's trying to set. Now for the third and final task. We're going to play a game using numbers and one specific sentence. Your goal is to identify this target. Smallest number that cannot be described in under 11 words. Let's count the words we just used to describe this number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We successfully named this number using exactly 10 words. But the sentence claims it cannot be described in under 11 words. Since we did it in 10, the rule is violated. This number is no longer what we said it was. This target number can't exist in our game, because the sentence we used to hunt for it accidentally destroyed the rules of the search. Game over. By now, you've probably realized that every single task I gave you was a deliberate trick. But think about the shape, the book title, and the number. What is the common thread causing all of them to break down? It isn't a lack of skill on your part. It's a structural flaw in the words used to build the rules. This trick is called the Berry paradox. It's named after G.G. Berry, a librarian at Oxford who first spotted this loop over a century ago. A paradox is simply a puzzle that has no logical answer. Language is a collection of symbols to share ideas, but things get messy when a sentence talks about itself. Look at our number. It gave a name in 10 words, while declaring it impossible to name in less than 11. You create a logical word loop the very second a description breaks the exact rule it's trying to enforce. Why does a logic loop like this matter outside of a few games and puzzles? It's a reminder that while our language is incredibly flexible, it isn't an unbreakable system. It pays to look closely at rules in the real world, because words can hide accidental tricks and loopholes we miss at first glance. Now it's your turn. Write your own rule-breaking paradox and leave it in the comments. Let's see if you can find a new way to break the logic of language.